Welcome to a new test and teardown video. This time it's another multimeter, another analog multimeter from Philips, the 2504. And as far as I can Google, this one is from 1975 to 86. So I think this is the range. This one was manufactured or sold. I really like this bench model. It's quite big, but with a very, very good meter, good size meter. I think it is very, very similar to the, so this is the table version, the 2503. I don't know. The meter itself is okay, this height, okay. So it's the same size of the meter. The glass here is just a little bit smaller. Maybe the scale and everything here is actually completely the same. So it's probably the same mechanical unit in there, the meter. That will probably be, the same. This one, however, got a lot of ranges for volts and a lot of ranges, for everything. It's really, really nice to see this meter with all those ranges, milliamps and amps. So that will be 1 amp to the front, and look at that, 10 and 30 amps on the rear. Wow, isn't that something? Diode test, and if you push a little bit, push and turn, you'll get access to the fuses, and they're really nice and kind to write the specification. So a 2 amp fuse for a 1 amp range. Okay, so this will be voltage and ohms. What kind of fuse? What does that say? 125 milliamps. But this works very, very nice and easy. Push, turn. The classic Philips switches. Oh, this is the feature I really, really loved about the 2503, and this is of course exactly the same in this meter. For an analog meter, it's really nice to know if it's positive or negative, and it's just shown using this little extra analog meter. Super, super nice feature. And of course there is a handle. You can use it to place it in the right angle. So this is the rear, exactly what I said. 0, 10 amp, 30, 1 amp. Really? The meter goes to 30, okay? So it's probably just continuing a little bit. I don't understand exactly why that is bad. What is that good for? Is this a fuse or a trim or a... It says something about a 0? Calibrate. What exactly are you calibrating here? We've got a reference output. So is that input or output? External 9 volts DC, but they forgot to say what is positive. Normally that will be indicated. I hope there's a diode. I better consult the schematics. Also, I was looking a little bit in the manual about the batteries, and it says 4 cells. It looks a little bit like 3 cells. I think we should have a look in here first. Oh dear, look at that. Ooh, and a little bit of goopity goop. So that will be a lot of sub-C cells. 6 of them. Yuck, it's still a little bit wet, isn't it? I don't know about that. So I think I'm gonna try and power it up. It looks like, okay, what I can do is maybe put in my connector here and measure what is connected to ground, maybe. I give up finding any good useful information in the manual. It's just absolutely not clear about the DC power connector. They assume you're going to buy exactly the right original power supply. Well, this is like 50 years old, or 40 to 50 years old. So that's not going to happen. But look, in here we got the red and the black wire. This is the back side of the battery compartment. So this is my lead. Also, I'm looking here. This will be the top of the batteries, right? And this one is mounted this way. So if I'm looking at a minus here, that will be positive in the other end. So this is a double verification about the color codes. So okay, the red one is positive. Thank you very much. So far so good. And this one goes to the mechanical switch in the DC connector. So that means when you plug in the DC connector, see this happens, and you disconnect the battery, and then the positive in your outer ring of your DC connector is now going to the blue wire. And that goes, of course, to the on-off switch. The black wire here is connected directly to that black wire from the battery and to the PCB. So far so good. I just ohmed those two wires. So those wires are just the thinnest, most flimsy stuff. But of course this is more than enough, but it's just, really? And half of the case is just air. Look at that. It could have been a lot smaller. And what is that? That looks a little bit like an extra fuse. Really? Is that a fuse, or what is that? No, that is not a fuse. This one is a voltage, over voltage spark over. So there will probably be gas in here. So it's a GDT, gas discharge tube, right? So that is the over voltage spark over. And here we got the switches and a shield for the switches. And the fun thing is this plastic, or this kind of PVC that are around those two wires, it's like sticky. When I touch this, it's like touching a, I don't know, touching a snail or something. Yikes. So now the unit is powered up by 9 volts and it's using 5 milliamps. There's a fun thing, Pam-a-lam. Look at that. And then it discharges. So there's probably something with the reference voltages or whatnot. So let's try and power it on, and then it's ready. I have short-circuited my wires here and selected ohm, and I'm now in 10 ohms for full range. So again, this one works the other way around. Your test leads, they're shorted, and then you adjust for 0 ohms. Like this. If you open, smack, it hammers the meter to maximum. Obviously, this is, the meter must be designed for this kind of hammer to the max. I really don't like it so much, because look at this. Look at that. Ready? Pam. This can't be good. But definitely this is how it's designed. The knob on the back that says cal is what you dial to get 0 when you have the input shorted. It is a little bit annoying that it is different. Okay, let me show you guys this. Now I will short the input. And now I have adjusted for 0 in the 10 ohm range. Obviously, it's going to be a little bit different, see? Now I need to calibrate again. Now I need to calibrate again. And in all the different ranges. See, a little bit less, a little bit more. So the zero is wandering around a little bit. So this meter here is just a 2 ohm. So 10 ohms for full range is fine. You can see 1 ohm, you can see a half an ohm. Maybe we should try and see how, if this is really true. Let's just go to the 10 ohm again. Oops, why isn't it 0 now? Let me do that. I really tried to zero the best I could. And here is 1 ohm. Of course, this is the very, very far end of this meter's capabilities. And it reads a little bit under 1 ohm, wouldn't you say? So it means reads 0.8. Okay, let's try another one. And this resistor is a 0.47. And again, it's reading a little bit low. So I think we should go up a few ranges and see if everything is more happy. I believe this is 100 ohms. And I also believe my resistors work. I did pay attention to the calibration. And I do believe this is 100 ohms for full range. So that must be this one. And we're reading 85. I am not happy now. Let's go up a few notches here and see if it's better zero again. And I believe this is a 2K. We're in the 3K range. I did all this fancy zeroing, and it's a little bit off. Well. Let's see if there's a pattern, if this repeats in the voltage ranges. Now, I've been playing a lot with this in the different volt ranges. And this is the 3 volt range. And the unit is off. And I've been poking around with this one a little bit. There's a little bit of mechanical hysteresis, so it's a little bit difficult to catch the zero. Also, I think the two different zeros, this one and that one, isn't really exactly the same place. Say, if I go up, see, now I have a 0 on the top one, and then now I have a 0 on the bottom one. They're not exactly, but I guess this is just, I don't know. This is what you could maybe expect. So normally I would assume you trim in this with the meters off. Okay, now it's on and it's still the same place. Let's come with 2 volts floating, not connected to the, I need to push this in a little bit more. Ugh. I would call this 2 volts. There is a trimmer on the back called Cal. Let's try and play with that one a little bit. So now I got a finger on the Cal on the back. Oh yeah, see? This is exactly what I mean. Now I got 2 volts. Happy. So let's try some other ranges and see if it's okay. I don't know what to say about that. I will call this the 30 volt range. So this is where we're looking. And this one shows 16 and something. But I got 15. So why are you doing this to me? Do I need to clean something or Do I need to poke a little bit more with this? Is this the... No, it's still going exactly the same place. So, I think there is a little bit of a problem. It was also a problem with the ohms not being super accurate. I am not so impressed again. Back to 1 volt, and we're now in volt. Okay, and not just way too much. Let's put it 900, and it's actually quite a lot off. So that is what I expect to find, a burned resistor or something like that in here. So I think it is teardown time. We're gonna open and see if there is any visual damage to this unit, and let's see how it's built. So this is the top. It's really well shielded. We also got some screws here from the other side we need to take out to get access to everything. But look at that sense resistor. Holy camole, that is big. This is my finger. Really? And it is made of some quite thick and heavy duty. So this is how they calibrated it, depending on where you solder the two signals. Isn't that something? So that was just the Mega Shield. Again, it's made in really thick material. Whoa, is that really necessary? And it was... I took off 2 screws I shouldn't have taken out. So that is a shield or thermal. Because I see a temperature sensor and 2 power diodes. That's a little bit funny. Ah, okay, of course. Now I see there'll be the DC current through some diodes. So it doesn't matter how you put this AC or DC, right? Going through calibrated resistors for the current. We got a trimmer for AC voltage compensation. I could really have enjoyed some stickers on the PCB or some silk screen indications on the trimmers. What are they doing? So it's not a try and error or go and poke around with schematics in a very, very bad quality. It's not always you can find good schematics for stuff. But of course, since this meter is just way off anyway, and I didn't find anything that is broken. So I think somebody who didn't know what they were doing poked around with the trimmers, and this is why this thing is just off with like 10% or so. And this one should easily be within 1%. Look at that. 0.25% resistors. And that will be some of the voltage dividers and stuff. But other than that, it's pretty beautiful design. I do see some snotty snot here around. Maybe it's because they cleaned the PCB with something that wasn't really clean, or they spray coated it or something. We do really see some high impedance circuits here, and some dual fancy circuits. But it's actually quite beautiful design, and this entire section of switches is of course in a shield. 5 sections of a lot of, again, super custom with all the different how to do this and how to do that. Maybe we could clean this a little bit, but I didn't see any change when I moved the switch, and this is normally what you see. If there is a problem with cleaning, just move it a little bit and tweak it, and you'll definitely see. Absolutely sexy, this sense resistor. Yeah, we'll probably play a little bit with this, see if I can get it more accurate. Let's consult the schematic and see if there's any information here. At least what I see here is 40 something. Oh yeah, this one is 470k, 407 ohms, 100k, 470 ohms. Again, yeah, I was kind of hoping there were different values, all of them, so I could, you know, pinpoint them on the schematic. And then there's another one down there. So I just need to try and error a little bit. Not exactly what I want to do. This is not how you do science, is it? That is a funny resistor. Maybe that is not a resistor. This is maybe more like an inductor. Yeah, that's what I think it is. Yeah, and again, this one is the cal, and this is affecting the voltage. It's not affecting the ohms. And this one is the 0 for the ohms, and it is quite small and very close to this. Imagine this one is outside, so it's gonna be even more impossible to touch this. Why the heck wasn't this placed somewhere where they could have a long pen something or long shaft? Maybe put it on the other side, right? Have it so it goes out here, or here. You know, easy peasy. Why can't it be easy? This is just impossible. Just saying, Philips, you didn't do it perfect. The more I play with this, the more buggy it gets. Oh man, I am in ohms, and look at that, it's just going up, and it's not really sensitive. Now it is completely open, and you see, it is not affected by hands touching anything here. So of course it should be able to work without the shields. And what do you know? It's just going and going and going. And why? Because this is the reference. There's a 1 volt reference output on the back, and it's just going all the way up and up and up and up. And if I dial a little bit around here, see? Whee, look at that. So this is just the different ranges of ohm. It's just getting completely hammered around here, and it's not, has nothing to do with this. There's nothing wrong with this pot or that one. Of course, if I touch some of them, yeah, you will see. This is a good idea to see if this pot is active in this mode, or if it's, of course, anything that is related to references. I believe this has something to do with the references, right? But this is just completely mad. And that is a little bit of a shame, because I totally love this view, and it is in mint condition. Look how beautiful it is. But damn it, it just don't work, this one. Ay, bad luck. Let me see if I can show you this at the same time, because I actually found the problem. See, I'm now in ohms, everything here is open, and it is just this crazy, and it just continues to go up. And if you see, this is the fantastic transistor here. If I try and heat this up a little bit, see how little I just go near it. See, now it says 2567, right? So, okay, I touch the metal, and see, I heat it up and it stays up. It didn't actually respond when I touched it, but only after a little while when it got heated up. See, now I touch, and then I go away. So it's a temperature thing, it's a thermal issue with this component. It is just crazy sensitive. There's definitely nothing I can do about that. I did actually manage to find something on Radium Museum, as you can see here. This is a really good page to find all sorts of schematics and documentation. And this is the problem. So this is the dual fed in this construction that is causing all sorts of thermal problems. Let's look at the schematic around this part. I'm sorry, this is okay, I can just help you. So this is how it is. Very high impedance circuit, DC coupled. See, here is probably the offset stuff. If this part, trimmer here is not accurate, they will be different. And then all this will sail away because there is no feedback to this system. So this is where you trim this problem. So that is the 403, and the 403 is that one. Oops, that one. Here's a fun thing. In voltage mode, remember on the schematic, the two FET switches around this one, they switches actually the behavior of this circuit. So that means here in voltage mode, see this one I input 6 volts and I am in the 10 volt range. So what I can do is, here now it shows a little bit too much, and all the way in the other end, it shows a little bit too little. And this part here is now not, okay, this is because I touched this one, right? But if I touch the part only, heat it up and all that, I don't see a whole lot. It's just because I touch everything else. So now this area is dead as the grave. And that is because now it's used in another configuration. Let's put it back in the middle. And here is the voltage and the amp calibration. And now I'll just put this for 6 volts so it's accurate. And then I'll just live with the fact that this thing can't measure any ohms, because when I go to ohm, it just goes funky monkey on me. And I really don't know exactly what is causing the problem. Annoying! Why are you doing this, you silly thing? And my patience with this one is running out a little bit, I must say. I can't spend too many hours, too many days on this. It should be quite simple. And sometimes it is just not that simple, is it? Nobody, nope. It's just sailing and sailing and sailing, which is a little bit annoying. And also you see the thing with the voltage reference in voltage mode. See, this is the voltage ref output. And if I go to ohms, see, it starts being good. And then it just sails and sails and sails away. And it stops at 1.3 volts or something like that. I can help it by, see, I can help it a little bit by just cranking this one a little bit. Funny thing is that now it's not that bad as it, yeah, okay. Here we go again. Yep, the meter with the defect resistance thingy funky. What? I was hoping to find a part that will just go absolutely bonkers on me when I touched it. Probably like a diode or a capacitor or transistors or something like that.